Hello everyone, welcome to class 5 of our cybersecurity series. So today we are going to talk about the OSI model and protocol analysis. And the objective of this course is to understand OSI model, its layers, protocols, and how real life or real world traffic flows through network. We are going to make use of Wireshark to analyze data packets practically. Then our learning objective is that at the end of this course, students should be able to explain each of the 7 OSI mode layers, their functions, the real-world analogies, identify common protocol used as each OSI layer, understand the process of data encapsulation and de-encapsulation, compare OSI model versus TCP/IP model in modern networking, use Wireshark to capture and analyze real network packets, linking them to OSI model. So last week we did an introduction to OSI model. We talked about networking, talked about network devices like the switch, the routers, the hops, and the rest. The NIC card, where we said it have an interface like the ET0 interface. We did justice to that in our last class. So today we're just going to basically focus on the 7 OSI model, which we say it is what? OSI stands for the Open System Interconnection. It's a conceptual framework that standardizes how different systems communicate in a network. So the OSI model can be explained using this table. We start from the layer 7, which is the application layer. We give it a description that it is an interface for user and apps. So basically, this is the closest interface to the user. And it works with protocols such as HTTP, FTP, SMTP, and DNS. So with HTTP, you know that it is talking about web applications. FTP has to deal with the file transferred applications, and SMTP, that is the web emails, mail servers, and the rest. Then DNS has to do with the domain name resolution that resolve our domain names to IP address. So we have the presentation layer, which we talked about last week. It deals with the data encryption, decryption at the other end, and then compression. So it actually does a lot of job to make sure that data are being encrypted and can only be decrypted by the layer, by the devices it needs to be decrypted by. So it has protocol like the SSL, which is the secured socket layer, the TLS, transport layer secured, the ASCII, which is the standard way of presenting letters, the JPEG, which is standard way of representing image format. So the session layer controls session between application. I said that each time a connection is made between the client and the server, they have established a session, and they exchange session keys. The server can work with the public key, the client can work with a secret or private key, where the client needs to use each time is making requests to the server. This ensures that this connection is secure, that even though attacker sniff into the network and have access to the data, he won't be able to see anything that is going on between the two system. So this is the layer that ensure that those things are met. So it has to do with the protocol like the NetBIOS, the RPC, the PPTP. Number 4 is the transport layer. Transport layer is reliable delivery, error control. So it ensures that data actually gets to where it's supposed to get to, and then it tries to check, that's what we call checksum kind of errors, that check for error in each of the packets, and then can even request for the packet if it sees that maybe the packet that is being sent is being corrupted. So protocol that works in this layer are the TCP and the UDP, which is the transport control protocol, and the user datagram protocol. So then we talked about the third one, which is the network layer. We said there's the logical addressing and routing. So it ensures that each of the packet that is going out has a source IP and a destination IP. This ensures that these packets are being known across the network, so that it won't be delivered to the wrong network device or the wrong system or the host. this layer also ensures that it finds the smallest or the shortest path to reach its destination. So it has protocol like the IP, the ICMP, the IPsec. We said the IP is the Internet Protocol, ICMP is Internet Control Messaging Protocol, and the rest. So the second one is data link layer, which is physical addressing. We say that each of the devices across the network have a physical address that is encoded and cannot be changed, except on a very serious case, like maybe a pen tester is trying to conduct an attack. It can be changed for some reasons, and then it works with the Ethernet, the ARP, and the PPP. Then the last but not the least is the physical layer, which we said have some electrical slash optical signal, has to do with hardware. So things like the cable, NIC, Wi-Fi, hops are basically working on the physical layer. So there's a little way of remembering all these layers, because at some points you won't be able to have them at half head. So just having this mnemonics have helps you remember each and every layer in the OSI model. So just using all people seems to need data processing, where the all is for application, the people is for presentation, the sim is for session, the two is for transport, the need is for network, the data is for data link, the processing is for physical layer. Okay, so let's talk about protocol at each layer. So here's how real protocol map onto OSI layer. The application layer, where we have the web and email, it has protocols such as HTTP, which is the hypertext transfer protocol, HTTPS, which has to do with hypertext transfer protocol secured, SMTP, which is the simple mail transfer protocol. Then the file transfer, which has to do with the FTP protocol, DNS resolution, which is the DNS server. So at the presentation layer, which is the layer 6, we have encryption, which have a protocol like the SSL, secure socket layer, the TLS, the transport layer secured, and then encoding formats such as the AAC, II, which is the it's I think the standard encoding for text. Then the JPEG, which is the standard encoding for images, and the MP3 is for music and videos. Then we have the session layer, which manages connections. We have something like the NetBIOS, the RPC, the SMB. Then the transport layer, which is the layer 4, which ensures that a data is being delivered to a destination. It has to do with reliability and reachability. So it has some protocol like the TCP, which is the transfer control protocol, the UDP, the user datagram protocol, basically used in most of the streaming app like the YouTube and the rest. So network layer, which is the layer 3, has to do with routing, and the routing comes with a protocol like the IP, which is the internet protocol, and some diagnostics too have some protocol like the ICMP, which is used for ping and trace route. So ping is actually a diagnostics tool that is used to check if a destination is actually reachable, and then the trace route out know the path it takes to reach that destination. So we are moving to our data link layer, which is the layer 2, which I said it has to do with MAC addressing, and each of the devices across the internet have a hard-coded MAC address which cannot be changed. So it has to do with Ethernet and ARP protocol. Then framing and switching. So when data reaches data link layer, it becomes a frame. So we have the physical layer, which is we talked about the hardware, and it has to do with the cabling, the switch, the hop, the Wi-Fi. There is a bit transmission via electrical or optical signal for fiber optics. So data encapsulation and de-encapsulation. Data encapsulation. When data is sent from your computer, it is passed down through the OSI layer. Each layer has its own header, creating a package that look like this. So the application layer, the application header, the presentation header, session header, transport header, example the TCP, which has to do with the ports that is actually sending the request to. The network layer, which has to do with the IP address. A data link layer, it deals with the presentation, presents the MAC address of the destination and the source MAC. Then the physical bit, which is transmitted over a wire or Wi-Fi. So the encapsulation on the receiving side, the packet travels up the OSI layer. So each layer removes and interprets its corresponding header. This structure allowed clean separation of function and easier troubleshooting. So we have the OSI versus the TCP/IP model. We have looked at the OSI model as 7 layers, but the TCP/IP model kind of group those layers. They group the application layer into one by taking the presentation layer and joining it to become the application layer. Then they have the transport layer, then the network layer, which is otherwise known as the internet layer in TCP/IP layer, and then the data link layer is the data link layer and physical layer is grouped into network access layer in the TCP/IP model. They actually work with almost the same protocol. So in our hands-on lab, you're going to have an introduction to Wireshark. We do some ping tests, and we looked at how the data is being transmitted from our device to the internet to the DNS server of Google, and then we looked at the responses from Google server. We filter some protocol like the HTTP, the IP address, and the ICMP, and kind of a thing. So we do some filtering there. So we check some packet encapsulation and then the rest. So let's meet at our Kali Linux system. Welcome to our lab environment. So we are going to look at how we can capture these packets with Wireshark and then try to have some packet analysis on the captured packets as well, and try to look into DNS packets, and then try to look into network packets and the rest. And for some reasons, my VM was configured. For some reasons, my VM network is offline, so I'll be trying to use my vulnerable server as my targeted system. You can also actually use domain name as well, but for some reasons I am offline, so I'm going to make use of that. We are still going to analyze the packets anyways. So first things we want to do is try to ping our vulnerable server to see if it's actually reachable. So I'm pinging it now. So I have sent like 5 packets have been transmitted, and then 5 packets have been received, meaning that it is actually live and it is reachable from my system. So 0 packet is lost. So I'm going to start our Wireshark now. So sudo Wireshark, then password. Okay, so when you're starting your Wireshark for the first time, it will ask you for the interface you want to capture the packet, or for the interface you want to monitor. So ETH0 is actually the interface I want to monitor at this point. We have other interface like this, my Docker interface, because I've actually installed a Docker on my Linux system. This is the loopback address, which is the 127.0.0.1, and the rest. You have a lot of interfaces you can look. The Wi-Fi interface is also there, but for now let's just focus on the ET0 interface. So you can see it has started capturing data. I would say if this is the first time you are looking at the Wireshark, you might get confused and you might get overwhelmed, but I will tell you to relax. It's not that tedious. It's very simple to know. It's just for you to understand the logic behind networking and you are good to go. So let's just try to ping our server again. I'm going to split my screen now, split it right. So then I try to increase it from here. Okay, so we try to ping that server 10 variable server was 10.111.213.142. So we sent a ping. So you can come to your Wireshark. You notice that there will be some ping. Okay, so look at it. ICMP packet, ICMP packet, and the rest. So I'm going to stop capturing. I'm going to stop capturing for now. So why I'm capturing a lot of packets is because this my VM. I am connecting my card. My network interface is being connected to my home router. So a lot of things are going on the Chrome that is in my host system. So that is why a lot of packets is being captured. So it's even good that those packets are being captured so that we will understand packet filtering. So if you want to filter a packet based on its protocol, for now you can look at this is the number of the packet, this is the time it was captured, this is the source IP. We talked about an IP address. We said that IP address is used to identify every device in the internet. This is the port where it sends the traffic to. Then this is the destination IP address. Then this is the destination port. Then we looked at the protocol as well, the length of the data, and then information. Some meta information are also available here. So once you choose a packet, you can choose to analyze or to have a better information of how those data we transmitted, or it was how it was being framed, and then you can look at it from the framed, then the Ethernet layer, and the internet. There's like the IP layer where you look at the IP address. You look at this is the source IP address and the rest. So each of the layer you can take a close look at it from here. Each of the that we discussed the data link, this physical, the IP layer. So basically, this is where you get an opportunity to have a peep of the data that is being transmitted at each of the layers. So you have to choose a packet, and then you tend to look at it as well. So let's filter our ICMP kind of packet, ICMP packet, ICMP. So you can look at these packets. Okay, so you can see this packet was transmitted with the source IP 10.111.213.19, which is our own IP address. We talked about it in our last class. Then the destination IP, which is our vulnerable web server or our vulnerable server, is then 10.111.213.142. You can see. Let's go here. You can look at this. Wow. So let's just try and stop this. You can look at this, that this is the ping to this 10.111.213.142. So that's actually the packet that we are sending it to, which is a vulnerable server. Then the protocol is ICMP. Then the length is this. The length is 98. Then the info about the packet we are trying to echo ping requests from this. You can take a look at each of the segments of the packet. So this is the frame at the frame layer, which is it's actually trying to tell you that 98 bytes was transmitted across the wire, and it was encapsulated on a data type. Encapsulated type is Ethernet 1, and arrival time, and then a lot of things. The echo arrival time and the frame marked false, the protocol in frame, and the rest. So this is the Ethernet layer. You looked at the destination MAC address and the source MAC address as well. This is the internet protocol layer. You have access to look at the IP address, the source IP, destination IP, and a lot of things. So look at this, the source address, checksum status, which was unverified. and the stream index, which is 19, destination address, and the rest. So I can collapse this, and then the message itself. So this is the identifier, which is the 5, sequence number, the response time, then the data, and look at the data. So this is the data that was transmitted across the network. The length is 40. So you can see that the length of the data is 40 bytes. Then after all this has been added, it results in 98. Maybe all this IP address, MAC address, and the rest, the status, the checksum status, and the rest of it. So you can see that this is a ping request, and then this is our server reply, because this is a reply, this is another request, this is a reply, this is another request, this is a reply. So that is how to filter a packet in Wireshark. So if you go back to this, you can see a lot of interesting things. So look at this. Let's look at this. This is a packet which has an resource IP 10.111.213.55. This is our host system making a request, a DNS request, using the port 55979 to this destination 10.111.213.70. Then the destination port is 53. DNS, this is the port for DNS, and then the protocol is DNS is making a query to a DNS server. You can take a look at the kind of queries it made from it. It was a domain query. So it was requesting for an IP address of beacon 5.gvt3.com. So it was requesting for IPv4 address of this site. So, and the rest of it, you can see that after it made that request, after it made that query, there was actually a IPv6 query as well, and then I think there should be a response. Yeah, this is the response. So this is a response from the source now, which is the server. It made the request. Then the host system is now the destination kind of address now. So that is actually the reply it made. So you can see is an answer 1 from the question. So this is the answer, which it has returned an IP address of this site, the beacon 5.gvt3, and it's returning what authoritative name server address of this. So that is actually how to work with Wireshark filter packet. You can actually filter this packet even before capturing the packet, but it's best you capture all the packets and filter it from here. So like HTTP can filter. You can see we have only one HTTP. That means a request was made from this source IP 3.333.252.61 using the port to this destination, and then destination port as well, HTTP protocol, and then it was this error was being returned. So we have come to the end of this practical demo on packet analysis and OSI model. I hope that you will join us in our next series. Thank you.